Hello, welcome to my YouTube channel Raise a Cat, and today in the physics section we will be starting with concept of work done. Okay, so what is the concept of work? So this is very important topic. So to know these concepts, it is very important for both Neet and JEE. So work done can be defined as force into displacement. Okay, work done is defined as force into displacement. Okay, so what is displacement? Displacement is nothing else but the net distance traveled by any body. So what is displacement? It is the net distance traveled by any body. Okay, so net distance traveled by any body. Okay, or mass of the body will be m. Okay, so and the dot product displacement dot product with force. Okay, because the dot product we can do A dot B or B dot A will be same. So displacement dot force or force dot displacement, both are same things. Okay, and work is a scalar quantity. Work is a scalar quantity. Okay, so it is not a vector quantity, so that's why dot product between two vectors which are force vector and displacement vector. Okay, so for example, there is an angle of 60 degree between force and 60 degree angle is between force and displacement vector. Okay, so the work will be F force vector dot displacement vector into cos of 60 degree. This will be our work done. Okay, so like this we will be able to find the what is the work. Let's see now what are the different types we can find the work done. Okay, so let's see what is the graphical method to find the work. Graphical method for calculation of work. Okay, so how graphically work is calculated? Suppose that there is this graph of force versus displacement. Okay, and this is graph. Okay, so area under this force and displacement graph will give us work done, because work done is defined as integral of force into displacement dx. So various dx elements, suppose that this was the graph of force versus displacement, this, so like this we will calculate by taking these rectangular elements. So small rectangular elements we will take, and this whole graph will be formed. Okay, so like this we can calculate by integrating force into displacement dx. Okay, so area under this force and displacement graph will give us the work done by any body. Area under force and displacement graph will give us work done. Okay, so this is the graphical method of finding this work done. Okay, so for example, there is one example. Let's take one example. Okay, so suppose that this is the graph of force versus displacement, and this is like this. This is straight line and this is again like this. Okay, suppose that this is 2, this is 4, this is 6 and this is 8. Okay, this is 2, this is 4 and this is 6. So net work done will be sum of all the areas. Net work done is equal to sum of all areas of force versus displacement graph. Okay, so how we will do this? 4 minus 2 into 2 will be 4, plus 6 minus 2 into 4 will be 8, plus 8 minus 6 into 6 will be 12. Okay, so net work done will be 24 joules. This will be net work done. Okay, so this is the work done. By this we can find graphically. Okay, so how we will find? Let's take one example by calculating this work in the vector form. Okay, vector form. Okay, so suppose that there is one vector of force which is defined as 3I plus 2J plus 4K. This is the vector of force, and vector of this displacement D is 2I plus 9J plus 3K. Okay, so this is the vector of displacement. Okay, so we have to find the work. Okay, so work will be force vector dot displacement vector. Okay, so what will be there? 3I plus 2J plus 4K dot 2I plus 9J plus 3K. So this will be the work done, force dot displacement. Okay, so 3 into 2 6 plus 18 plus 12. Okay, so it will be 36 joules. Okay, so this will be our work done. How we will find? In the, if the vectors are of force and displacement given and representation is vectorial. Okay, so like this we can find. Okay, so if the, let's see some main points of displacement which we have to remember. Okay, so for example, our displacement is 0, not the distance. Suppose that distance is, the distance is 30 meters, but the displacement is equal to 0. So the work will be 0 only, because the formula of work is force into displacement. Okay, so suppose that there is one man who has taken this mass m and move here and then came back here. Okay, at the same place. So what will be the work done by the man? Because it has came to same place, work done is equal to force into 0, because the displacement is 0 here. If the man has came to same place, so displacement is 0, because the displacement is net distance, so the work done will be 0 only. There will be no work done. Okay, so suppose that some mass m is taken at the height h, and again to a height of h, like this. Suppose that this ball has gone up to the height h, again height h, then height h2, then height h1, like this, then height h2 it has traveled, and then like this h3, and then it has lost its velocity 0. So here some velocity is there, suppose that 10 meter per second, now it's 0. So it has finally came to ground, it was there in ground. So net displacement is 0. So net displacement is 0. So work done is 0 only. No work done will be there in this case, because the ball has came to the same place, so no work done is there. Okay, so like this we can find. Okay, and one more thing, like there are two types of fields in which work done can be there. Okay, so there are so many types of field: electric field, magnetic field, like this. That fields are there. So there are two types of fields: conservative force field and non-conservative force field. Okay, so these are the two types of force field in which the work done is there. Okay, so in conservative type of force field, no work or no heat is generated, or no energy loss is there. No energy loss. Okay, in this the energy loss is there. Okay, in non-conservative force field. Okay, so this was for the work introduction part. Thank you.